Today, let's talk about the third factor affecting rate of reaction, and that is surface area. Experimental procedure. Measure 50 cubic centimeters of 2 molar hydrochloric acid and transfer into a conical flask. Measure 2 grams or 2.5 grams of marble chips, that is calcium carbonate, and add the marble chips to the acid in the conical flask and start the stopwatch immediately. Record the time taken for the reaction to come to completion. Measure again .50 cubic centimeters of 2 molar hydrochloric acid and transfer into another conical flask. Measure 2.5 grams of marble chips and grind into powder using mortar and pestle. Transfer the ground marble chips or the powder marble chips into the conical flask containing the acid and start the stopwatch immediately. Record the time taken for the reaction to come to completion. If you look at those two experiments, they have same reactants. The only difference is that one has unpowdered marble chips, while one has powdered marble chips. We have used the same amount of marble chips. We have used the same amount of the acid in question. So dilute hydrochloric acid reacts with the marble chips, which is a carbonate, to produce metal salt, that is calcium chloride, carbon 4 oxide, and water. Let's have the reaction. Calcium carbonate plus dilute hydrochloric acid leads to formation of calcium chloride, carbon 4 oxide gas, and water. To balance the equation, we have 2 as a coefficient of the hydrochloric acid. The volume of this gas produced per unit time is what is used to determine the rate of reaction. Volume of the gas produced is used to determine the rate of reaction, and that is cubic centimeters per unit time. Volume per unit time, cubic centimeters per second, and that is the rate of reaction. Reaction is faster at the start due to high concentration of reactants. Increasing surface area of particles, that is by grounding the powder or grinding the marble chips into powder, increases the surface area of contact of the reacting particles. The greater the surface area of contact between the reacting particles, the higher the rate of reaction. Therefore, in the reaction between the ground marble chips and hydrochloric acid, there is a shorter time to get to a production of the carbon 4 oxide gas. Why? Because there is increased surface area of contact between the marble chips and hydrochloric acid. It therefore means that that kind of reaction will take place very fast, leading to production of carbon 4 oxide gas. However, in the case where we have unpowdered marble chips, the reaction will be there, yes, but there is the surface area of contact between this acid and the carbonate is low, and that's why the gas will be produced but at a lower rate. There will be low volume of carbon 4 oxide gas produced during that reaction. What do we conclude? That increase in surface area of the reacting particles increases rate of reaction. Let us illustrate these 2 instances graphically so that we are able to see clearly how a surface area really affect the rate of reaction. X-axis, Y-axis, so we want to have the one for smaller chips, and the one for larger chips. Now This is for larger chips, the unpowdered, and then this is smaller chips, the powdered marble chips. You can see that the rate of reaction is higher. Takes very short time for the reaction to complete compared to the one that becomes flat after a very long time. So this is shorter time to start producing carbon dioxide gas, then this is taking longer time to start producing the same carbon dioxide gas. For solids, reactions occur at the surface area, and we have seen that in the reaction between marble chips and HCl. When the surface area is increased, the rate of reaction of solids increases proportionately. This is demonstrated by the reaction between a magnesium, maybe ribbon, and HCl. We can have magnesium ribbon, magnesium powder reacting with HCl. We can have, like we've seen, marble chips and HCl, that is smaller ones and the larger ones. And the conclusion we have here is that when the surface area is higher, then there is a high rate of reaction. And when the surface area is low, then there is a low rate of reaction. So this implies that increase in surface area increases the rate of reaction. By increasing the surface area of contact between the reacting particles. Good. That is all about rate and surface area.